Hi everyone, welcome to the last video. I know in the last video I promised to do it with the calculator. It completely slipped my mind when I was recording it. But really, it's not anything you haven't seen before. You just would have put the quadratic equation into the calculator and used the maximum function, which we've seen before, to figure out what the vertex is and read off the coordinates off the screen. So it was really nothing that special. So I don't feel like I need to go back and edit that video in. So this one is going to be about projectile motion. So this section of the book, we're going to model projectile motion as follows. Is the height of an object is going to be its height at time 0 plus minus 16t squared. So this negative 16 is going to be the effect due to gravity, which is something you learned about in physics, or if you take Calc 3 at some schools. But there is no accounting for things like atmospheric, wind resistance, that kind of stuff. So this is still a pretty unrealistic model, but this is the one we are going to do. So this is height at t equals 0. So we have this person who is on a cliff, and there was some water down there. So the nice thing about this is I can draw the water in blue. Yay! So the question is, when this person at the top jumps off to dive, at what time does that person hit the water? So notice I drew this very parabolic for that reason, because this person, well, they're actually going to dive like this. They're going to be standing on the edge here, and they'll dive like that. So this is the actual vertex where they're standing at. And so we know that this is going to be at t equals 0 because that's before they jump, at the exact moment they jump. So we know that the x-coordinate is 0. So how high of the cliff is just really going to be the y-coordinate right here. So what we know is that at t equals 2.5, h of 2.5 is 0, because this is going to measure height above the water. So this is the surface of the water is going to act as the x-axis, and so when we hit the top of the water, we're hitting the x-axis, so we know that the y-coordinate is 0. So and actually we don't even need to put this in vertex form, because actually this is enough information to be able to solve for h naught. So we know that 0 equals h of 2.5, but that actually also equals h naught minus 16 times 2.5 all squared. So we just run those numbers into our calculator. Times 2.5 squared, and I get negative 10, or it will equal h naught minus 10, and adding 10 to both sides gives me that the height is at height 10, and I believe this is in feet. I guess whatever, let's see what the units are. It actually gives me no units, so we're just not getting units. We'll say feet, for example. Or meters, or whatever the units are. It's the problem to give me units, so I'm not going to assign units. So it's at height 10. And that's all there is to these type of problems. So basically, you just kind of need to know this basic formula and apply it to the problem. And that's it. And that's all for this section on quadratics, and that's everything we have for this week. So I'll see you next week.